In this problem, we're asked to find the domain of the following function. Now, when you see the word domain, you should be thinking to yourselves, what are the values of x that I can plug into this function and get a real number value out of the function? There's two places to look. The first is to think about when this function possibly will not be defined. What can go wrong? So we can see that we're going to be dividing by x squared minus 5x plus 4. So let's factor that completely to get a better picture of what to expect. So we leave the denominator alone, and we factor the bottom as being x minus 4 times x minus 1. Now, if we ask ourselves, when is this function not defined, well, we can say f of x is not defined whenever we're going to be dividing by 0. So not defined when the denominator, which is the product x minus 4 times x minus 1, is equal to 0. That's a nice factored quadratic equation that we can solve. X minus 4 equals 0, or x minus 1 equals 0, so x equals 4, or x equals 1. The other thing we have to keep in mind is that we have a square root as part of the definition of this function. Now, square roots are not always defined to give us real values out. In fact, we need to insist that what is underneath the square root is positive or 0. So we say f of x has real values when the square root of 2x minus 3 exists. And that's only going to exist if 2x minus 3 is strictly greater than or equal to 0, which is a nice inequality we can solve. Add 3 to both sides, divide by 2, and then we have x has to be greater than or equal to 3 halves. So now where does this leave us? We know that x cannot equal 4, cannot equal 1, but has to be greater than 3 halves. Best way to summarize this is looking at a real number line. So we know we need to avoid 1, we need to avoid 4, and then in order for this function to be defined, x has to be greater than or equal to 3 halves. So there's 2, we can say there's 3 halves, and it has to be everything above 3 halves. Now, how do we describe this? Well, we use interval notation. We can think of this as being two intervals. First is the interval from 3 halves to 4, including 3 halves, so we use the square brackets, not including 4 because if x equals 4, the denominator is 0, union 4 to infinity. So the domain of f is the union of these two intervals.